Hello everyone, I hope you are learning and enjoying my videos. In today's video, we are going to talk about a new concept, a new chapter, that is speed time distance. It's very interesting and important topic from exam point of view. So let's get started. I'm sure you must have come across a formula of speed time distance, that is speed equal to distance upon time, right? So this chapter will revolve around this particular formula. We have different ways of writing this formula. Say speed equal to distance upon time. We can also say distance is equal to speed into time. We can also say time equal to distance upon speed. Okay, so how will you remember? Again, the way we try to remember work and time formula, work equal to efficiency into time. So here I have distance divided by either speed or time, depends what you want to find out. Suppose if you want to find out distance, then distance is equal to speed into time. If you want to find out time, then time equal to distance upon speed. If you want to find out speed, then is speed equal to distance upon time, right? So remember this circle: distance, speed and time. Now we have a unit conversion. Okay, so we will usually see the unit of distance as kilometer and unit of time as hour. Okay, so unit of speed become what? Kilometer per hour, right? If you see meters and seconds, then the unit of speed will become meter per second. Okay, now what is the relationship between these two units? So the relationship is, I hope you know, 1 kilometer is 1000 meters, right? Kilo means 1000, kilogram 1000 gram. Okay, and 1 hour means it will be how many seconds? 1 hour has 60 minutes and each minute has 60 seconds. This will become what? 3600 seconds, right? 3600 seconds. So if I say 1 kilometer per hour, that will give us 1000 meter by 3600 seconds, right? Okay, if you simplify this, okay, by cancelling zeros and further cancellation, you will get 5 by 18. So that will get you a conversion number. What is the number? 1 kilometer per hour, that's equal to 5 by 18 meter per second. So this conversion you should remember. What is the multiple constant here? 5 by 18. What does it mean? Suppose if I say 5 kilometer per hour is nothing but 5 into 5 by 18 meter per second, right? Okay, so kilometer per hour converting into meter per second, you multiply by 5 by 18. Remember this number. Okay, if you do other way around, as in suppose if you have meter per second, and from meter per second you want to convert that into kilometer per hour. So that conversion will be reverse. 1 meter per second and kilometer per hour, it will be reverse. It will be 18 by 5, right? So what will be the multiple constant or the number by which you multiply for unit conversion here? 18 by 5. So remember this. Okay, we are going to use it in different situation, different questions. So we will revise, we'll come back to this number. But as of now, if you remember one conversion, that's enough. 1 kilometer per hour, that is 5 by 18 meter per second. 1 kilometer per hour equal to 5 by 18 meter per second. Alright. Now let's solve some questions based on what we discussed. Question said a bus travels 720 kilometers in 20 hours. Calculate its average speed in meter per second. So one way is you can convert 720 kilometer into meters. So 1 kilometer equal to how many meters? That's equal to 1000 meters, right? So you multiply by that. So you will get distance in meters. And similarly, this 20 hours you multiply by what? 3600. Yeah, 1 hour equal to how many seconds? 3600. That's the conversion number, right? So 20 hours you multiply by 3600, so that will get you conversion into seconds. Okay, and then you can divide. Else, I suggest you to calculate the speed. Calculate the speed here in kilometer per hour itself. Okay, so how much is that? So speed equal to distance 720 upon time, that is 20, right? Distance upon time. Okay, so that if you simplify, what will you get? 20 ones are and 20 3s are 60, then 6 are 120. So you will get 36 kilometers per hour, right? That's the speed. Now, if 36 kilometers per hour, if you have to convert this into meter per second, by which number do you multiply? Kilometer per hour converting into meter per second. Yes, you are right. You are going to multiply this 36 by 5 by 18, right? Then you will get meter per second. I hope this is clear. I hope this is pretty easy to understand. 1 kilometer per hour converting into meter per second. The multiple constant or the number by which you multiply is 5 by 18, right? Okay. Now what? Simplify. 18 2s are 36 and then 2 5s are 10. So 10 meter per second. Yeah. 36 kilometer per hour will get you 10 meter per second. Okay. Yeah. What is the objective of this question? This objective of this question to remember the multiple, the number by which you multiply to convert kilometer per hour into meter per second. Okay. Great. Next question. Now this video, I hope you know that this is first video of speed time distance. So I am going to start with scratch, with basics for the people who do not know basics of speed time distance, right? So if you are already aware about this conversion number, you are already aware about the formula, you can jump to the next video. Okay, but I still advise go through it, do not skip, so that we will use the same terms when we solve questions. Let's see question number 2. A person covers a certain distance in 6 hours. If travel at 40 km per hour, okay, if he has to cover the same distance in 4 hours, then his speed must be how much? Yeah, okay. So by first condition, when you travel with 40 kilometers per hour, that means if the speed is 40 kilometer per hour, he takes how much time? 6 hours, right? Yeah, we need to find out the speed when he has to cover the same distance in 4 hours. All right. So by using this, we can find the distance, because we have to use the same distance for the second condition. What is the second condition? That he has to cover the same distance in 4 hours. Then what should be the speed? Okay. Yeah, I know most of you must have got the answer by now. Alright, okay. But still, let me solve for all of you. So distance, what will be the distance formula? Distance, if you want to find the distance, height distance. Distance is equal to speed into time. Yes, distance is equal to speed into time. Yeah. I will draw this again. Distance, speed, time. So distance is equal to speed into time. Speed is 40 km/h. Look at the unit. Are units same? Km/h, and here also time is in hour, right? They are same. So you can directly use the formula. If the units are not same, first you have to make units same. Okay. So 40 km/h multiply by the time, which is 6. So distance is how much? 240. What is the unit in this case? Distance unit will be kilometer, right? What is the unit of distance here? Kilometer. In speed time distance, you have to be very careful about units. Okay, you need to check the units are same or not. Okay. Now the same distance covered in 4 hours. So what will be the speed? Now if I want to find out the speed, speed will be equal to distance upon time. So speed equal to distance, which is 240, upon time, which is here how much? 4 hours, right? Simplify, what will you get here? You will get 60 km/h. That's the new speed. If the person wants to cover same distance, what was the distance? 240 kilometers in 4 hours, then that should be the speed formula. Alright? Well, great. Okay, easy questions, easy questions. Okay. We got a new concept here. New concept. If speed is speed and distance, what is the relation between speed and distance when time is constant? Okay, we have recently covered ratio proportion. If you remember, we have recently covered what? Ratio and proportion. We have discussed directly proportional and inversely proportional here, right? Directly proportional and inversely proportional. What is directly proportional? If one side increases, other also increases. If one side decreases, the other also decreases. What is inversely proportional? If one increases, the other decreases. Inverse impact, right? Okay. If you remember in ratio topic, when we were discussing, when I started, I told you that speed and speed time distance is one of the application of ratio proportion, and we see this happening. So speed and distance, what is the relation when time is constant? So speed is directly proportional to distance when time is constant. Okay, when time is constant. When time is constant. Yeah, I hope you will remember this. Okay, when speed is directly proportional to distance, when time is constant. If time is changing, then you can't say they are directly proportional. Okay, speed is directly proportional to distance only when time is constant. All right, great. Okay, so in this case, if speed increases, distance also increases. What does it mean? Suppose if I drive my car with 40 kilometers per hour, or I reach I take or maybe say in certain time I cover a distance which is 10 kilometers. So it's quite easy to look at. Okay, which is 12 kilometers. Now in the same time, time is constant. In the same time, if I have to cover 15 kilometers, then the speed should be more or less. Think about it. Speed should be more or less. If distance increased, Okay, and I want to cover the same distance. I want to cover this increased distance, which is 15 kilometers in this time, in the same time as previous. In that case, I need to increase the speed also, right? Just think about it. If distance is more and time is same, then you have to increase the speed. Yeah, increasing the distance, also increasing the speed. Okay, or vice versa. For example, if you say 40 kilometers per hour, you cover 12 kilometer in some time. We can calculate the time here because we have speed and distance, both of them are given, so we can calculate the time, but that's not what we are trying to learn here. We are trying to learn here, if I increase the speed, if I travel with the speed of 60 kilometer per hour, tell me one thing, if I travel with the speed of 60 kilometers per hour in the same time as previous, will I be able to cover more distance or less distance? Will I be able to cover more distance or less distance? Of course, more distance, because if I increase the speed, I will be able to cover more distance, right? That's how they are directly proportional. Okay, one increases, other also increases. I hope this is fine. Great. Another concept is speed and time. What is the relation between speed and time when distance is constant? Okay, when distance is constant, what is the relationship between speed and time? So you will find here the relationship is inversely proportional. How? Think about it. Say you travel from your home to college, okay, or maybe your workplace, and the same distance. Now, if you have to travel in less time, the same distance here, now you have to travel in the less time, will you not increase your speed? You will increase your speed, right? If you have to cover the same distance, you got less time. You have to cover the same distance, you will increase your speed, right? So what is the relationship between speed and time? If distance is constant, remember, if distance is constant, then it is inversely proportional. If distance is constant, okay, if distance is constant, speed is inversely proportional to time. So time is inversely proportional to speed. Yeah. So relationship is what? Inversely proportional. Okay. One increases, other decreases. Okay. Will you remember that? Yeah. Let's revise this. Speed and distance directly proportional. Speed and time inversely proportional. Okay. Speed and distance directly proportional when the third element, which is the third element? Time, when time is constant. Speed and time is inversely proportional when the third element, which is the third element here in the second case? Distance, when distance is constant. Okay, great. I'm sure this is clear. Pretty clear here. Let's look at a question. Let's look at one question. So here it says a car travels certain distance in 2 hours, and the train travels same distance is constant, in 40 minutes. What is the ratio of speed of car and train? Yeah, okay, fine. Let's come back to this. Speed, distance directly proportional. So if time is constant, when time is constant and speed and distance directly proportional, that means we can also say the ratio of speed, S1 is to S2 is to S3, ratio of speed of the first object relate to second object relate to third object is equal to the ratio of distance covered by the first object is to second object relate to third object. Okay, because they are directly proportional, so S1 is to S2 is to S3 equal to D1 is to D2 is to D3. If you are not understanding this ratio or the proportional, then you have missed my video of ratio and proportion. Please go through that playlist once again. Okay. Alright, you can also say speed 1 by speed 2 equal to distance 1 by distance 2, directly proportional. Alright, inversely proportional, inversely proportional, inversely proportional, inversely proportional. It means ratio of speed of first object relate to speed of second object relate to speed of third object is equal to inverse 1 upon T1 is to 1 upon T2, time taken by second object relate to time taken by third object, reverse, yeah, inverse. This also means S1 by S2 equals to T2 by T1, inverse, yeah, T2 by T1. Okay, please note this one and this one. I hope you are having pen and paper with you when you are watching my lectures. Please don't watch it just for namesake. Okay, make notes, then only you will improve. Okay, it's very important to make handwritten notes. So I hope this is clear. S1 is to S2 is to S3. Speed of first, speed of second, speed of third ratio equal to 1 upon T1 is to 1 upon T2 is to 1 upon T3. We can also say speed of 1 by speed of 2 equal to time of 2 by time of 1. Inverse relation. Okay. Now come back to the question. Now if I want to find the speed, ratio of speed of what? Car to speed of train, then that should be equal to time taken by train inverse by time taken by car. Just think about it. Inversely relation, right? Just now we have seen S1 upon S2 equal to T2 by T1. T2 by T1, yeah? So speed of car to that of speed of train should be equal to time taken by train, inverse by time taken by car, right? Now think about units. The unit here is hour and then unit here is minutes, right? So time taken by train, what is the time taken by train? Time taken by train is 40 minutes. Alright, no problem, 40 minutes. I have to make sure that I write the time taken by car also in units, what? Minutes, right? In what unit? Minutes. So here I got 2 hours, multiply by 60 to convert hour into minutes. So that will get you minutes. 2 hours, how many minutes? 2 hours has 2 into 60, yeah, 60 minutes per hour. Alright, I hope this multiplication is clear to you. Yeah, 1 hour equal to 60 minutes. Remember this. If it is not clear, then you should make this clear now. 2 hours will be 2 into 60 minutes, right? Because we have to have units same, I converted this 2 hours into minutes, right? This will get you speed of car by speed of train. Simplify this. 20 2s are 20 3s are, cancel 2 1s are 2 1s are, right? So what is the ratio here? Ratio is 1 upon 3. Ratio is what? 1 is to 3. Ratio of speed of car is to speed of train, that is equal to 1 by 3. Okay, easy, simple, clear? Okay, so that's how inverse relation between speed and time work. Okay, let's look at the next question. Here we have walking at the rate of 4 kilometers per hour a man cover certain distance in 3 hours 45 minutes. Running at the speed of 12 kilometers per hour, the man will cover the same distance in how much time? In how many minutes? How many minutes? We need to find out in minutes. Alright, we'll do it. So, kilometer per hour. Speed units are same. Yeah? The unit of speed here, kilometer per hour and 12 kilometer per hour. So, that's pretty fine. Like this is same, this is fine. Units are same, right? Okay, units are same. Some cosmetic changes and we say units are same. Okay, fine. Okay, so if I want to find out the time taken, what do you need to find out? The time taken in minutes, right? I can directly say, without finding the distance, I can directly say speed while he is walking divided by speed while he is running. Okay, that should be the time taken by what? Inversely proportional. Time taken by walking or running? Time taken by running. Correct. You are absolutely right. Divided by time taken by walking. Okay. Inverse. See SW here and TW here. Okay. Inverse. Alright. Now substitute the value. Let's substitute the value. While walking, the speed is 4 km per hour. Alright. 4 km per hour. While running, the speed is 12 km per hour. 12 km per hour. That's equal to time taken while running. Oh, that we need to find out. Okay. Divide by time taken while walking. So time taken by while walking is 3 hours 45 minutes. Do you want to convert into minutes? You can convert into minutes. Okay, if you want, you can convert into minutes. Yeah, otherwise just keep it simple. Yeah, see, 3 hours 45 minutes. Look at this. Look, see how am I solving. Yeah, when you see numbers are easy and easily relatable, here you can see 1 by 3. Yeah, so 3 3s are, the 3 1s are 3 and 15 3s are 45. Yeah, so somehow they are directly cancelable by 3. They are directly divisible by 3, right? So I can say time taken by while running is equal to, if I take this here, that is 3 hours and 45 minutes, yeah, divide by 3, I can say 3 here, that's 1 hour, and if you cancel 45 minutes by 3, it will be 15 minutes, right? That's the time taken by running. So, I mean, that's how I treat. Like I'm not, I'm not very big fan of calculating in advance. When it's needed, do the calculation then. Or if you are not comfortable, sir, kya kar rahe ho? What are you doing here? Like, can you please simplify further? So if you want to do that, you can convert 3 hours into minutes plus 45 minutes. 3 hours is equal to 180 minutes. If you add another 45 minutes here, you will get what? 2 to 5 minutes, and this you can substitute here, and if you do the calculation, you will still get the same answer. Okay, so that's up to you. I am leaving this up to you. 1 hour is what? 60 minutes plus here 15 minutes. Okay, so time taken while running is going to be 60 plus 15, that's 75 minutes. He's running for 75 minutes. That's quite a good time, no? For running, like you run 75 minutes continuously. It's quite a good time, If you try on treadmill, if you go to gym, try on treadmill, or you can try running otherwise also. 12 kilometers per hour ka speed se 75 minutes running all the way. It takes courage. Well, but this is the answer. Okay. So as I said, if you use this as the time taken while walking, if you use this as time taken while walking, you will still get the same answer. Okay. So I am leaving the calculation up to you, but I hope concepts are clear. Concept is clear here. Concept is clear here. Thank you. Let's look at the next question. So next question here this says, find the ratio of the time taken to cover two distance in ratio 4:5, 4:5, two distance in ratio 4:5 to that of speed which are in ratio 4:3 respectively. Okay. Now can we simply divide these two numbers? Why I am saying divide? Because we need to find out the time, right? So time equal to what? Time equal to distance upon speed. So can we simply divide the ratio of distance by ratio of time and get the answer? I advise to avoid this because see, these are two different relations. Do you remember ratio proportion concept? Yeah, they are two different relations. This is 4:5 and this is 4:3. So multiple constant for this ratio and multiple constant for this ratio might be different. Yeah, there is a chance for that to be different. Yes, so do not attempt to divide directly, although you will see that it's not relevant, but do not try to divide this directly. You might have some catch in between. Okay, so better of assuming value, So first ratio of distance is given. Now I am using assuming method in ratio. Do you remember assuming method in ratio? When I have ratio 4:5, I can assume that to be 4x and 5x, remember? And the other ratio is 4:3. Can I assume 4x and 3x? No, I need to take different multiple constant, right? Let me say 4y and 3y, right? Okay. Now what is this? This is distance as per question. 4:5 was the ratio of distance, right? So what do you get here? Distance. What do you get here? You get time, right? Now if I want to find out, no, not time, this is the speed, my bad. 4:3 is the ratio of speed. So what do you get here by assuming this? You get speed, right? Okay. Now if I want to find out the ratio of time, I will take, so this is distance 1 and this is distance 2. This is speed 1 and this is speed 2. So to find the time, okay, this time distance is not constant, so I can't simply apply inversely proportional. Keep in mind, I can't simply apply inversely proportional because distance is not same. You got different distance here, 4:5. Okay, distance is not same. Time is inversely proportional to speed only when distance is same. Distance is constant, right? So what do you get here? You get speed, okay, you get time 1 as distance 1 by speed 1, right? You get time 2 as distance 2 by speed 2, yeah? Okay, assuming you people are beginners, I am solving this question for beginners. Okay, so here if I find the ratio, it will be 4x by 4y equal to 5x, no, not equal to, ratio, no, so it's to 5x by 3y. Now tell me one thing, to simplify, can't I say this 4 ones are 4, 4 ones are 4, right? Now that's in ratio. So do you see the common number between these ratios, x upon y, x upon y? Can I cancel? Yeah, can I cancel x upon y and x upon y? I am assuming that you have gone through my ratio playlist, yeah, my ratio videos. I am assuming that. So ratio here, I can cancel the same term x by y and x by y available in both ratios, so I can cancel them. Okay, what do I get? I get 1:5 by 3. How do I simplify? I can simply multiply this by 3. Yeah, remember, fraction, you multiply by something, multiply by LCM of the denominator. Are you able to recollect the ratio concept? How do you simplify the fractions number and get the simple ratio? You take the denominator, LCM of the denominator, and you multiply by that. So you multiply, what you get? 3 here, yeah, and then 5 into 3 by 3, so 5 here. So you get 3:5, right? You can also do this way. This T1 is nothing but x upon y, yeah, and this is 5x by 3y, that's fine. And if I want to find the ratio of T1 by T2, I will say that is equal to x upon y here divided by 4 upon 3, yeah, so 5x upon 3y, and you remember denominator will become numerator. So if I simplify x upon y divided by 5x by 3y, that will get me x upon y multiplied by 3y by 5x. So this way y cancel, x cancel, so ratio is simply 3:5. Same thing, yeah. So I'm leaving this up to you, that how do you handle this. But are you comfortable? What is learning from this question? Learning from this question is, you can only say the time is inversely proportional to speed when distance is same or distance is constant. When it is not constant, you cannot do that. Okay, so I hope this is clear. So what we have learned in this video, we have learned the formula, speed equal to distance upon time. Remember this circle, distance, speed and time. We have also learned, if distance is constant, time is inversely proportional to speed. If time is constant, distance is directly proportional to speed. Alright. So well, this is it in today's video. My name is Shyam Manavat, signing off. I will see you in the next lecture. Till then, stay happy, stay healthy. Bye-bye.